Alright, so today is day 2 of graphing inverses. So we're going to be graphing some inverse functions and inverse relations here. So the notes portion will be rather short just because this is day 2, and then you'll have the remaining class time to work on the homework. So on this first one, we're given that the triangle ABC is formed by the points in the relation -1, 6, -7, 2, and -5, -3. What is the inverse of this relation? So remember, when we take the inverse of a set of points, we're flipping our x and our y values. So we have the point 6, -1, 2, -7, and -3, -5. So we want to graph the original triangle ABC and its inverse. So triangle ABC I'm going to graph in purple. So it's made by the points -1, 6, -7, 2, and -5, -3. So it tells me that it's a triangle, so I'm going to connect those. And then I'll graph the inverse in red. So it's at 6, -1, 2, -7, and -3, -5. And then it says, what do we notice about the graph? And so what I can see is that there is a reflection across that diagonal. And so it is a reflection across the line y equals x. And that's what happens when we graph our inverses. They're going to be reflected across that line y equals x. So here we want to graph both functions, so the original and its inverse, and then we're going to look at how they reflect. So on this first one, we have f of x equals 2x plus 8. I'm going to graph that first in purple. Well, I'll graph it in black actually. So my y-intercept is +8, and my slope is 2. So I will connect those to make the line. So that's f of x. And then I'm going to find the inverse by switching my x and my y variables. So this becomes x equals 2y plus 8. And I'm going to solve it for y. X minus 8 equals 2y. Divide by 2. And so I get 1/2 x minus 4 is equal to y. So my inverse function is 1/2 x minus 4. So my y-intercept is at -4, and my slope is 1/2, so up 1/2. And there you can also see the reflection that's occurring across that y equals x line. Number 2, we'll do the same thing. I'm going to graph the line that we're given first, 1/3 x minus 1. So y-intercept at -1, and then a slope of 1/3. Connect them. So that line is f of x. And then we're going to find the inverse of f of x. So this is y equals 1/3 x minus 1. We're going to flip them. X equals 1/3 y. Oops, minus 1, sorry. And we're solving for y, so I'll add 1. We get x plus 1 is equal to 1/3 x. 1/3, I'm sorry, I said x, y, is the same thing as saying y divided by 3. So to get rid of that 1/3, I'm going to multiply by 3. So 3x plus 3 is equal to y. And then that means my inverse function is 3x plus 3. So for my inverse, I have a y-intercept of 3 with a slope of 3. And again, we can see that reflection across the line y equals x. On number 3, we're going to do the same thing. We're going to graph this original first. We have x squared minus 4. Remember, with our quadratics, the parent function is y equals x squared. So I can just look at the transformations that happen between the parent function and this new function. And so my regular parent function starts at 0, 0. I'm going to move that down 4 points. I'm going to be at 2, 4. I'm going to move that down 4 points. And reflect it. And so here is my quadratic. That's f of x. So we took the parent function of x squared and we moved it down 4 points, since we have that minus 4 in the end there. And now we're going to take the inverse. So x equals y squared minus 4. Add 4. Add 4. X plus 4 is equal to y squared. So then we'll take the square root of both sides. Remember, when we take the square root, we say plus and minus. So plus and minus the square root of x plus 4 is our y. So the inverse function is plus and minus the square root of x plus 4. If you don't know how to graph that, that's fine. You don't have to be a master at graphing. What you can do is draw in that diagonal, that line y equals x. And then reflect your points across it. So this point would be here. This point would be here. This one's not right. So this one. And so once you reflect all your points, then that is what your inverse function would look like. So on the homework portion today, you have 15 problems. The first two you're you're giving the inverse of each relation and then determining whether they are 1-to-1. Remember to be 1-to-1. Both R and R inverse have to be functions. If one's not a function, then it cannot be 1-to-1. So you do the same thing with the graphs on 3 through 5. 6 through 9, you're finding the inverse. So what we did, minus the graphing portion. And then on 10 through 13, we're going to determine whether they are inverse functions. So I'm going to do one of those. And then on 14 through 15, that's like what we did on the notes. So I'm going to do 10 just to show you how we determine whether they are inverses or not. So if they're inverses, f of g of x equals x, and g of f of x equals x, which sounds like it'd be really hard to prove, but it's not. So what I'm going to do is I'm going to color code. So my f of x will be purple, and my g of x I'm going to write in red, just so we can see when we are replacing those variables. So with the first one, f of g of x, we need to replace inside f of x, g of x. So I'm going to write f of x 6. Now this is where I'm replacing. Instead of writing x, I'm going to write 1/6 plus 1/6x plus 5/2. And then we still have that minus 15. So that's f of x with the x replaced with all of g of x. Now we're going to distribute that 6. 6 times 1/6 is 1, so I have 1x. 6 times 5/2 is 15. And then I have minus 15, which equals x, because those 15s will cancel each other out. So f of g of x does equal x. Now let's do the same thing with g of x. So g of f of x would equal 1/6. Replace my x. Let me rewrite this really quick over here because this is f of g of x. There we go. So now instead of x, I'm writing 6x minus 15. And then I still have plus 5/2 on the end. Distribute the 1/6. 1/6 of 6 is 1, so we have 1x. 1/6 of negative 15 is negative 5/2. And then we have plus 5/2 there. So those two will cancel, leaving me just with x. So because I got x on both of those, we'd say overall that they are inverses. So then that is all for today's notes on graphing inverses. And then you have the remaining problems for your homework. Make sure you get that in on Canvas, and then I will see you guys in the next one.